Okay, so it says, suppose you're on a desert island playing dice with another castaway. The winner's prize will be the last banana. Here are the rules of the game. Each player rolls a die. If the largest value shown is 1, 2, 3, or 4, then player 1 wins. If the largest value shown is a 5 or a 6, then player 2 wins. Okay, so who do you think has an advantage in this game? Player 1 or player 2? Or neither? Make your best guess and explain your choice. Okay, so take a moment, write out who you think's going to win this one, and tell me why. And play the game 20 times with your partner, and record the winner of each game by tallying in the table below. Okay, so for instance, if me and Kyla are going to be partners, what's going to happen is I'm going to use my calculator to do the rolling, right, because we don't have any die, sorry. And you can go under apps, hit the button 0, hit button 0, hit enter, and then scroll down to where it says roll dice. And then when you roll, you're just going to press the button that says roll up here at the top. It's really the window button. And then you'll roll and then compare. Now remember, one has to be player 1, and you win if you got 1, 2, 3, 4, and that's the highest roll, right? And then player 2 wins if the largest value is a 5 or 6. Okay? So go ahead and take a moment and try this. Count up how many wins for each. All right, so as you're finishing up with your partner, one thing I want you to notice is that if you add these two together, you should get probabilities that add up to equal 1. So when you add them all up, they should equal 1. Okay? This is also called something called experimental probability. Okay, and y'all have used that term in the past, maybe in geometry. It's been a minute since you've seen it, but that's experimental since we set up an experiment, right? Okay. All right, so who won more often? So let's think about it really quick. Okay, there are how many possible outcomes for us? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Whoa, no, I missed that. Everybody had a partner? No. Did you get data though? Okay. All right, so we have 11, 12, because you would be playing somebody else, right? Okay, so 12 times 20, that's going to give us our total, right? Like total possible outcomes. Yeah? All right, so 12 times 20 is going to give us, how did I put that calculator? 240. Okay, so out of 240, how many total wins for player 1 from the whole class? Okay, so for instance, like I had 10 wins from our group. Okay, so Kyla, from y'all's group, how many did y'all have? For player 1, how many wins did you have? 7. Okay. David, 9. How many did you get? 10. 10. Okay. Jalen, how many y'all got? 10. Okay. All right, so that was 56 altogether. Okay, so we did 56 out of the 240. So 56 out of 240 is going to be 0.23. And whenever it says proportion, you're going to write it as a decimal. I don't want you to write it as a percentage. Okay, so that's 56 out of 240, and that's 0.23. Okay? Now, in order to figure out how much player 2 is going to be, we're going to take 1 minus 0.23. Okay? So if we're looking at 3b, we're going to take 1 minus 0.23. Okay? And this is called the complement. Okay? Complement. Okay? And so we're going to find that by doing 1 minus p not 2. Or 1 minus not player 2. Okay? You could also see this as p2 to the c power. That's just saying the complement of it. Okay? And so 1 minus 0.23. Wow. 0.77. All right. So now on number 4, it says to determine the true probability of player 1 winning, we should list out all the possible rolls that we could get. Okay, so if two people are rolling, they're saying, what are the total possible outcomes? The total possible outcomes is called the sample space. And y'all learned that back in geometry. Sample space. So for each of these columns, you're going to go 1, 2, 1, 3. So like list this number first, then this number second. You're going to do that for all your boxes. Okay, so take a moment, fill those boxes in. So you're going to have something that looks roughly like this. So you're going to use your table to find the probability of player 1 winning. Okay, so if you look at this, anything that is less than 5 or 6 that is rolled, that is the largest number, is a win for player 1. So everything that's inside, I think it's this space. Yep, anything that's inside of this space is player 1 win. Okay, so that is, and if you count up the boxes in yellow, 16 out of 36. Okay, which is the same thing as 0.44. Okay, so now the question is, which was closer to the probability you found in number 4A? Why do you think that? Your group data or the classroom data? So let's look at it. Okay, so for my team's data, we went and we did 0.5 here, right? Okay, we got 0.5 for our player 1. And then we got this 0.23. Okay, so which one was closer? Probably that 0.5, right? Now, let me ask you this. How many people actually were in this room? There was only like 11, right? Yeah, well, 12, but 11. So if we had more people, it would be a little bit more accurate. Remember how yesterday we talked about Miss Gallus's basketball thing, and within the first 10 shots, she looked like a baller, but by the time she did like 100 shots, she was like 0.4. Yeah. So like, which, I mean, nothing to scoff at, but, you know, like if she's going to be on, you know, any type of team, she's not going to make it. So on 4B, it should have been the class data was going to have the more accurate, because the class data had more games played. But we didn't see that because we didn't have enough data. Okay, so this goes back to the law of large numbers. And we talked about that, I think, on yesterday, day before last. Okay, so law of large numbers says that if we have many trials, then we're going to have more of an accurate theoretical probability. Okay, it's going to approach that. So your theoretical probability was this one. Thank you. Your theoretical probability is this one. So you actually calculate it based off of that table. All right, so for the important ideas, we've got the probability model. Okay, and that's listing, or it's a list showing all possible outcomes and their probabilities. And then they must add up to 1. And they must be between 0 and 1. You got to be between 0 and 1. So we saw that 0.5, we saw 0.44, etc. Okay. We also talked about the complement. And the complement is the probability of an event not happening. So this is going to be represented as P of A raised to the C power, or probability of the complement of A. Okay, which can be represented by this formula. You're going to see that formula on your formula sheet for sure. Now throw back to your geometry days because mutually exclusive starts to come up on this. Okay, so mutually exclusive means that events cannot occur together. Occur together. All right, and then general addition rule. So if you have the word or, then that means you're going to add your probabilities. Okay, so if you have the word or in there, you're going to add the probabilities. If you have the word and, you're going to multiply. Okay, but if you're mutually exclusive, that means that events cannot occur together. It can't be, I mean, it can be sunny and rainy, but like not normally, except in Georgia, right? I feel like that sometimes. You can't have one kid and two children. Like that doesn't make sense. You either have one or the other, right? Okay. So I want you to go ahead and start looking at your check your understandings. And then we're going to go over that in just a second.